So based on the last example, I'm just going to go through the steps here. We have r sine theta cosine theta, which we want to get in terms of x and y. We want to get it in rectangular coordinates. So like before, we have the following equations. Okay. Now we can just take it and figure out, well, I have sine and cosine. So it'd be nice if I can get an r in front of this sine and an r in front of this cosine. So what I can do here is, because I have an equal sign, is I can multiply this side by r, which is r squared. And I can multiply this side by r, which I have here and here. And here we get r sine, which turns into y, r cosine, which turns into x, and then we get r squared times r, which turns into r cubed. So we get something really nice. Because I want everything in terms of x and y, I can take this r now, which I have over here. R equals the square root of x squared plus y squared, which I can then substitute that in here, and we get a nice rectangular coordinates right here. Now, if we want to find the area, again, like the previous problem, we have that formula. We know r is sine theta cosine theta. Our bounds are a to b. We're still finding it from 0 to pi over 4, so that hasn't changed, so 0 to pi over 4. Now we're just taking this r equals sine theta cosine theta and substituting in for r. Well, if I square r, I'm actually squaring both these terms, so I'm getting sine squared times cosine squared d theta, which we can then put in the calculator to get this nice value, which I'll show in another video. And lastly, we're still finding the area of a sector, arc length. So the arc length formula here, just like the previous problem. Here I have another r is sine theta cosine theta. Well, to find r sine theta cosine theta, we have to use the product rule if we want to find the derivative. So the product rule of sine cosine theta is this f prime g plus g prime f. In other words, this is my f and this is my g, and I'm going to do the product rule. So it says f prime, so the derivative of sine is cosine. G is just g, so I just drop the cosine. Put a plus. And then the derivative of g is the derivative of cosine, which is negative sine. And then just f, so sine, I just bring that down here. And I can do a nice combine. Cosine times cosine is cosine squared theta. Plus and a minus gives me a minus. Sine times sine is sine squared theta. So now I know what my dr d theta is. Now that I know my r, my dr d theta, and I know that I'm integrating this from 0 to pi over 3, I can put that on my formula. A and b becomes 0 and pi over 3. R just turns into sine cosine squared, plus this dr d theta turns into what I found. So it turns into this squared d theta. And this is something I could plug it in the calculator, and I would see that I would get this value down here.